Hello, this is our third tutorial on solving equations algebraically. We've done the first two with the simple equations and the ones with the variables and the constants on both sides. This one is going to involve our second step in our DCID acronym with combining like terms. We've done the isolate, we've done the divide. We're going to add the C for CLT, combining like terms with this one. And we're also going to add the essential rule of math that goes with that, which is that we can arrange on a side. That doesn't mean to move things from one side to another. It's all staying on the same side because you can, I'm going to highlight this, change the order or regroup. Anything you want as long as it stays on the same side it was on originally. So that's what we're going to look at now. That's really the combining step. Although there are combining rules, they have to be like terms. You just can't like put anything you want together. They have to be alike. So I'm going to draw my line. I'm going to do this first one here. And I'm going to employ this thing that I've got over here so that we can look at it a little bit better. So on the left side, if I'm just looking at the left side, I've got the 3x, the 6, and the 2x. Okay, I can put things that are alike together. I can reorder them. So like if I want to, I can put my x's together up front. And if I put my 3x with my 2x up at the front, that gives me a 5x because they're both positive and it was adding. So 3x plus 2x plus 3x plus 2x equals 5x, and the 6 just comes down, and that's on that side. On this side over here, there's nothing that can come together. The 4x and the 13, they're not both x's, they're not both constants, so they don't go together, so I'm just going to bring them down like this. And what this was similar to when we were doing our sketching, because this is a similar step to the sketching that we did last week, was we would say, okay, I've got 3 x's, which is 3 triangles, and a 6 cube. And then I've got 2 x's. And on the other side, I would have 4 x's, 4 triangles, and a 13 cube. But we said, hey, these triangles, we can put them all together. So there's 1, 2, 3, 4, 5 of them. I can draw them all together, 1, 2, 3, 4, 5, and then put the 6 cube. And then I can just have my 1, 2, 3, 4 triangles and my 13 cube on the other side. So now I've got all 5 triangles together, which is the same thing as 5x. So it's the same basic concept as with the sketching, that you can regroup and reorder, but with the algebraic method, we call it combining like terms. So on this first example, there wasn't any distribution because we still haven't had parentheses, but we did just do the combining. So after the combining comes the isolate step. Remember, we want to get our x's together. At least I always start with my x's. So I want to get the 4x and the 5x on the same side. That starts the isolating process. In order to do that, I always like to go with the smaller or the fewer x's. Between a 5x and a 4x, 4x is fewer, so I'm going to move it. It's positive. Remember, we still use the opposite operation. So positive, opposite, that is negative. You can also think of that as adding versus subtracting. So I'm going to use a negative, and I'm going to think of this as a subtraction. 4x minus 4x, it makes it go away. But then I have to subtract on this side. So 5x minus 4x is a 1x. The 6 I just bring down. I didn't do anything with it yet. And the 13 I just bring down. I haven't done anything with it. Okay. I still want to get my x by itself. I'm isolating, so I'm in this I step, but I'm not finished with it yet because the x isn't by itself. I've got this 6 over there with it. Once again, we use opposites. So the 6 is connected with a plus sign. I'm going to subtract it because that's the opposite. And 6 minus 6 is 0. But then I have to do the same thing on the other side. The thing with the both sides from before still applies. So now I've got 13 minus 6 is 7. I'm just going to bring down my 1x. And 1x is the same as x. You can just use that as part of your box now. So my answer is x equals 7. And that was with that isolate step. Notice we did not need to use the divide step yet because we did not have more than one x left over. You use the divide step if you have two x's or three x's left over and you have to divide out. Okay, now I'm going to look at example 2. I'm going to start back here. I'm going to come down and grab my little box tool. And I am going to notice that there is no parentheses, so we don't need to distribute. So we're going to start with just the drawing of the line and look at what we've got here. Now, since there's no numbers in front of these x's, I'm just going to go ahead and put a 1. I like to do that. It makes it easier later when I'm trying to combine or move things around. And I'm going to come over here and I'm going to use my little box thing. Oh, my 1s are going to show up. That's okay. On my left-hand side, I notice that I can combine. I've got x's. Because if they have the same letter, then I can put them together. So 1x and 1x, that would be a 2x. And then the 5 just comes down. Now I'm going to check the other side. On the other side, I don't have x's that I can combine, but I have constants that I can combine. This 1 and this 7 can be put together. 1 plus 7 is an 8. I'm going to bring down the 1x in front of it. I can put the 1x behind it if I want, but I just like to have my x's first. So that's what I've got there. I have just now done the combining step. So the combining like terms, and notice this time we had combining on both sides. On the left side, we combined the variables with the x's. On the right side, we combined the constants, the numbers without the x's. Okay. Now I'm going to go to the isolate step. I want to get my x's together, and I always like to move my fewer x's. So between a 1x and a 2x, the 1x is fewer. So I'm going to move this 1x. Once again, it's positive. Think of that as a plus, so I'm going to use the opposite, subtraction, to make it go away. I'm trying to make like a 0 over here. The 1 minus 1 is a 0, so it's gone. But then I have to move it to this side and do the same thing. And a 2x minus a 1x is a 1x. Now I'm going to bring down my 5 since I didn't do anything with it. I'm going to bring down my 8. Okay. And I'm going to notice that, hey, my x is now combined up. I mean, I only have x's over here, no x's on the right side, but I've still got that 5 there. So I've got to move the 5, so I'm still in this isolate step. The 5 is connected with a plus sign, so I'm going to use a minus sign. And I'm going to use a minus sign on the other side. Those 5's cancel, and 8 minus 5 is 3. And I'm going to bring down my 1x again. And once again, 1x is just the same thing as x. So that's my answer. X equals 3. I did not need to use the divide step because I didn't have leftover x's. Now, I didn't check the first one, but we can go ahead and check this one. I'm going to just mark through this example. I'm going to use this space below to check it. And I'm going to go back up here to the original. Before I did anything to it, I'm going to look at how the original was written. I'm going to rewrite it exactly the way it was written. Okay, but everywhere that there is an x, I'm going to put in that 3 because that's what I'm saying, that x is 3. So in place of this x, I'm going to put a 3. In place of this x, I'm going to put a 3. But that 5 is just a 5, so I'm going to leave it. That 1 is just a 1, so I'm going to leave it. But in place of this x, I'm going to put a 3. And the 7 is just a 7, so I'm going to leave it. I want it in blue. Okay. Now I'm going to add up the sides. So I've got 3 plus 3 is 6, plus 5 is 11. And on this side, I have 1 plus 3 is 4, plus 7 is also 11. So I get the same thing on the right and left sides, which means my equation balanced when I put in a 3 for the x. So that means that my answer really is x equals 3 is correct. Now I'm going to go to the next example that we're going to look at. Okay, this is going to be all the way down here, example 6. Once again, I'm going to notice that I have no parentheses, so I'm not going to do the divide step. Okay, and I'm going to draw my line. And as far as using my box, I'm going to redraw my box here. I'm going to reset my properties. Okay, and now I can drag it over. And I can notice that, yes, I do have some combining that I can do. I've got a 6x with a 3x. And this time the combining is a little bit different because I'm not adding them since this is a subtract sign. It's 6x minus 3x. So 6 minus 3, just think of the coefficients in front. 6 minus 3 is 3, but then don't forget to put your x with it. And then I'm just going to bring down my minus 5 because I didn't do anything with it. And then I'm going to look at the other side. There's nothing there that I can combine, but I will go ahead and put the 1 in front of the x since I didn't do that before. And then I've got my plus 7. So now I can get my little box out of the way. So that takes care of the combining step. Now I'm going to look at the isolate. I got to get the x's together and all by themselves. So in order to get the x's together, I've got a 3x and a 1x. I'm going to move the 1x because it's smaller. It's a positive, so think of that as a plus. The opposite is a minus. So 1x minus 1x is 0x's, so they go away, but then I have to do the same thing on the other side. 3x minus 1x is 2x. Then bring down your 5, but make sure you bring down the minus sign with it. Okay, and then I'm going to bring down the 7. Okay, now I still need to get my x by itself. So but now I've got two things with it. I've got the 2x and that 5. They both need to be moved. But I'm going to go back and look at what this isolate step says. You always do the plus or the minus moves first. That divide isolate step is the last. So I'm going to look at things connected with a plus or a minus first. And I'm going to notice that the 5 is connected with a minus sign, so I'm going to move it. Opposite of minus is plus. And that's going to make the 5's cancel because a negative and a positive 5 makes a 0. But then I'm going to plus the 5 over here. And 7 plus 5 is 12. And now I'm going to bring down the 2x. So that takes care of this isolate step. The last step is the divide. In order to move the 2 away, I need to divide because that's 2 multiplied by x. And the opposite of multiplication is division. So I'm going to divide by a 2. 2 divided by 2 is 1, so I just have 1x left, which is what I want. But then I have to do the division on the other side. 12 divided by 2 is 6. So I get 1x equals 6, and the 1 just becomes part of my box. That just means x is 6. And there's my answer.